Wagon wheels were fitted with iron rims to increase durability. It was a common practice to heat the iron rim before installing. What benefit would heating the iron rim have? In order to understand that, let us first look at how does matter behave when heated. Molecules in a solid are confined, vibrate about their mean position, hence occupying a certain volume. In this case, the solid is confined within the dotted yellow line. What happens when you heat a solid? The molecules will gain higher kinetic energy and vibrate vigorously, occupying a larger volume than before. This results in expansion of solid. Molecules of liquid have some freedom of movement. They can slide over each other. What would happen if we heat a liquid? If we heat a liquid, the molecules will gain kinetic energy. The molecules will travel larger distance and occupy greater space. This would result in the expansion of the liquid. Gases don't have a fixed volume. They occupy the volume of the container they are in. They travel with high velocities, colliding with each other and the walls of the container. When they collide with the wall of container, they impart some of their momentum. Change in momentum gives rise to a force. And force, or unit area, is pressure. And that is how gases exert pressure on the walls of container. What would happen if I heat a gas trapped in a fixed volume? The molecules will gain higher kinetic energy, traveling faster, colliding more frequently with the walls of container, and with greater momentum. This would result in the force on the walls of containers to increase, resulting in the increase of pressure. Hence, we can see that pressure is directly proportional to temperature. Greater the temperature, higher the pressure. If you had the provision to change the volume and in turn keep the pressure same, like in case of a balloon, or in our case a movable partition, what would you expect to happen if you heat the gas? Heating the gas will increase the kinetic energy of the molecules, resulting into greater collisions and hence increased pressure. If the pressure has to be maintained same, the number of collisions have to reduce. In order to do so, the partition is pushed back, increasing the distance traveled by the molecules and hence reducing the number of collisions and maintaining the pressure same. Hence we see here that the volume is directly proportional to the temperature. Increasing the temperature can result in increase in volume given the pressure remains same. On the other hand, if we were to keep the temperature same and reduce the volume, we would observe that the number of collisions happening per unit time increases, resulting into greater force and hence greater pressure. Hence we see that pressure is inversely proportional to volume. Reducing the volume increases the pressure, given that temperature remains the same. Or we can also write it as pressure into volume equals to a constant. If the initial pressure of the container is P1 and in the initial volume is V1, we get the equation P1 V1 equals to the constant K. And if we reduce the volume, the new pressure and volume are P2 V2, which will also be equal to the constant K. Hence in turn we can say that P1 V1 equals to P2 V2. This is known as Boyle's law. Now answer, why is the ring heated before fitting on the wheel?